All right. Hi, everybody. I just wanted to talk really quickly today about what next week and the future weeks are going to look like in terms of how you can get help on math. Particularly, you can obviously always email me and get help from me that way. But if you need other ways, this is kind of the rundown. On the next slide, you'll be able to click on all these links, so just know that. But I want to highlight we're going to have these daily math help sessions, and that's going to be with all of the math teachers. So say you don't like getting help from me and you want to go work with Mr. V, for example, you can go find his time slot on Tuesdays and Fridays, and you can go into this Google Meet and join him and see him to talk about math with him. My slot for this time, for this session, is Tuesdays and Fridays from 1:15 to 2 o'clock. You can see the kind of daily schedule on here. So don't be shy. You can go on here and get help on my stuff anytime from any of the math teachers from 12 to 2 on Mondays, Tuesdays, Thursdays, and Fridays. Not Wednesdays, but yes, otherwise. Okay, the other thing I wanted to talk about really quickly is just my other Algebra 2 specific opportunities. And so on Tuesdays and Fridays, I'm going to be reteaching things that we have already learned. So next Tuesday, which I guess is the 15th of September, I'm going to be reteaching everything from yesterday, today, and then Monday and Tuesday. So I'm going to make sure that we kind of cover all of that stuff before too late, okay? So that's going to be your opportunity. You can join that Google Meet and watch me reteach things that way. If you just need help and you want to sign in and ask a couple of quick questions once a week, you can come to the Wednesday office hours. And so that would be an opportunity for you to just be doing your assignments while I'm sitting on a Google Meet with you, and you can just kind of slide in and ask questions whenever you need those things. That's kind of our outline for the help sessions and everything for math. You can always email me and ask me to help you with something specific, and I will make a special Google Meet for you in that situation. But this is sort of the stuff that we're going to be doing every week for everybody, and then you can kind of add on top of that too if you need that. Today we're going to be talking about our first sort of big learning target for the year. This is learning target 9A. There are two objectives on this screen, and they are both going to be assessed next week on Tuesday. I'm going to see where you're at on those things. So your two objectives are, I can use explicit and recursive formulas to write terms in a sequence. We're going to work on that today. And then I can write and use formulas to find the nth term of arithmetic and geometric sequences. I know you don't really know any of that vocabulary today yet, but we're going to get into it today. We're going to focus on our arithmetic sequences today. We'll skip the geometric ones. We'll do the geometric ones next week. Okay, so your first kind of vocabulary here is an arithmetic sequence. And a sequence we can just kind of call any pattern. So we'll just write pattern here. But the thing that makes it an arithmetic sequence versus any other kind of sequence is that it has this adding rule. And so we're going to kind of explore what that means for us, but the adding rule means a really specific thing. So here it is. An adding rule means whatever you do to get from step to step is the same each step. So the step is like, this is step one, but this is step 2 and step 3. To get from step to step, what I'm doing here is I'm adding 2 every time. And so because this adding rule is the same every step, that's what makes this sequence an arithmetic sequence. The next one is also an arithmetic sequence. This is a little bit weird, but I am adding the same thing each step. It's just that this is an adding a -3 each step. You might be saying, well, why wouldn't I just call it a subtracting rule or a minusing rule? And you can. It's just that we want to be really consistent and really clear about what an arithmetic sequence is. And so I want to use this adding rule vocabulary so that we make sure that we're being really clear that the adding rule is you're adding a negative number. Both of these sequences on this slide are arithmetic sequences, and so they follow that adding rule, and you can kind of go from there. We can use all of the stuff we're going to talk about today to describe these two sequences. There's actually another adding rule on this slide, and so this sequence that I have here is an arithmetic sequence. The thing that I'm adding to get from step to step on this one looks like plus 2/3, plus 2/3, plus 2/3. If you don't believe me, you can check me. And if I'm wrong, email me. But I am adding 2/3 every step. 1/3 plus 2/3 is 1. 1 plus 2/3 is 5/3. You can check that. And so I have a common thing that I'm adding every step. So the thing that I'm adding every step is this 2/3, and the common difference is that thing that you're adding every step. So I'm gonna write, I guess I have this kind of written out. The thing you add to get from step to step is called the common difference. So our common difference for this sequence is 2/3. It's positive, it's plus, because I'm adding it. If it was decreasing, if the sequence was going down, then I would be adding a negative number for my common difference. Okay, on this slide we have an arithmetic sequence, but we have sort of a specific kind of formula for this. We have a recursive formula, and a recursive formula has some really specific stuff going on, but I'm gonna just kind of see if I can puzzle out what's going on this slide first, and then we'll talk about what a recursive formula is. So here's the deal. I have A1 right here. It's given to me. It says A1 is 12. Done. I just copied that down. I don't have to do anything else with A1. This is where it gets tricky with these recursive formulas. A2, now this n is our step number. And so if I need to know what A2 is, then what that means is for this problem, n is 2. So I need to figure out, okay, how do I get step number 2 for this sequence called A? So I'm gonna put, do you see how that 2 is where the n is here? So I'm gonna put my 2 in here. So I'm gonna put in A, and then I'm gonna write 2 minus 1, because that's what this formula says. It says take your step number and put in the step number there, but then subtract 1 from it. And then it says minus 3 at the end. Okay, so now I need to do a little thinking here. I need to go and say, okay, well, what's 2 minus 1? 2 minus 1 is 1. So now I have, this is A, not 2 minus 1, but I can just write A1. And then it says minus 3. Wait, though, I know what A1 is. A1 says 12. So I can rewrite this as 12 minus 3. And so if I have 12 minus 3, I actually know what 12 minus 3 is. It's 9. So I have my answer to A2. A2 is 9. Okay, so now let's do the whole process again. Let's figure out what A3 is. A3 is, the formula says put the step number in and take 1 away from it, right here, right there, and then it says minus 3. Okay, so what's going on here? I have A, not 3, but A2, and then I'm subtracting 3. Well, what's A3? A3 is, or I'm sorry, what's A2? A2 is 9. So I can write 9 minus 3. Well, 9 minus 3 is 6, so I'm done. So A3 is 6. I can kind of keep going with this process, so I'm going to do one more, and then I'm going to kind of look at my pattern and see what's going on here. Okay, so last one. A4 would be previous step, that's 4 minus 1. So step 3 is really what that means, minus 3. So I'm looking at what's going on in step 3, A3, and then I'm subtracting 3. Well, A3 was 6, so I can take my 6 and then subtract 3 from that. And my answer is now 3. Okay, so now let's just take a pause here so I can write A4 is 3. I'm just going to highlight some stuff here so that we can see it. I have 12, and then I have 9, and then I have 6, and then I have 3. What's my pattern? Well, how am I getting from step to step? What's my common difference? So I want to pause the video here. At this spot, I want you to tell me what the common difference is at this point. Okay, common difference, what am I adding to get from step to step? Well, I'm adding a negative 3. Adding a negative 3. Every step, adding a negative 3. So it would make sense to take my A4 and subtract 3 here. So my A5 has to be 0. Okay. We have identified the common difference, and I just want to highlight that my common difference is showing up in my formula right here. This is my common difference. And that's a really important part of this formula. This slide is kind of similar. It's just that I'm using now what's called an explicit formula. And so we're going to try to riddle out what this says, what this means, and then we're going to kind of formalize after this slide. So bear with me again. I'm just going to circle my step numbers. Now I notice that I have a B, and all that means is the name of this sequence is sequence B. It doesn't mean anything besides that. Where those 1, 2, 3, 4, and 5s are, that's where the N is in my formula. And so what I can do is I can take the step numbers and put them in for N in both places. So B1 is, okay, so I need to just kind of rewrite the whole thing. Negative 7 plus 4 times, well, N this time has to be 1. Whoops. Has to be 1. Minus 1. Okay, so wait. There's a little evaluating that I have to do here. My order of operations would say, okay, well, what's this first stuff that I have to do? I got to do this stuff inside the parentheses. So 1 minus 1 is 0. So I'm going to write negative 7 plus 4 times 0. Next, I would have to do this multiplication that's kind of hidden in here. So 4 times 0 is 0. So what I'm really doing is I'm doing negative 7 plus 0. Wait, negative 7 plus 0 is just negative 7. So my first term is negative 7. It's important we see that our first term shows up in our sequence right there, in the formula. Okay, let's do the second one. I'm going to just do the exact same thing. Negative 7 plus 4 times, okay, step number was 2 this time, minus 1. See, the only thing that I'm changing here is that I'm just changing the step number. Okay, so 2 minus 1 this time is 1. So I have negative 7 plus 4 times 1. 4 times 1 is 4, so then I have negative 7 plus 4. So then my answer is negative 3. So that's step number 2. I'm going to do it one more time, and then I'm going to look at the pattern. Okay, so I have 1 now. I'm going to look at the pattern now, and I want you to identify with me, what is the common difference here? Is there one? Is there not one? What is it? Okay, so you should have identified that the common difference is 4 here, which is great. I noticed that my common difference is showing up in the formula also. So that's really critical that we know that too. So if I know that my common difference is 4, then I should be able to take my 1 and add 4 to get from step to step. So now I can just kind of assume that this has got to be 5, and then I got to add 4 again. And so then my next step is 9. So now I'm done. I've gotten the first 5 terms from this sequence formula. Okay, at this point we have some formulas that we've seen already. We've seen this recursive formula once, and we've seen the explicit formula once. I want to highlight that there are some common things going on between the two formulas, but they're also a little bit different. So I'm going to say, okay, first we're given this first term. We're given the first term in both formulas. That's what our A1 is. So always our A1 is our first term. And I suppose I probably shouldn't have a equal sign, I should have a colon. So our A1 is our first term. This letter D is our common difference. And then the letter N, and it's in a bunch of different places, is our step number. Okay. I know that I haven't talked about this yet, but we will get to it probably tomorrow, probably Monday. Okay, so on this slide I have a sequence, and it looks like it's arithmetic, and I know that it's arithmetic because I'm adding a -3 each step. Okay, so our first step is to make sure that the sequence is actually arithmetic. Okay, and we've done that, so we know that it is an arithmetic sequence because it has a common difference. So we're done with step 1. Step 2 is going to be identify. And we need to identify all of the parts of the sequence. So we need to identify A1. We need to identify the common difference, which is D. And then we need to identify our step numbers. But that's kind of not that important because we're going to change our step numbers because this is a formula. So we really just need to find A1 and D. So what is A1? Is our first term, and our first term is 16. What's our common difference? Our common difference is -3 because we're adding -3 each step. Okay, so then our step 3 is just to use the formulas. So my recursive formula, I'm just going to write R. So I'm going to create this entire formula. Okay, so I need to write out, what is the first term? Well, A1 is 16. I found that already. AN, so any step number, you have to go back to the step number before that, AN minus 1, so the previous term, and look back, and then what do you do to it? You add your common difference, which is -3. And then you can just copy the rest for n is greater than or equal to 2. Again, we're going to talk about what that for n is greater than or equal to 2 thing. We'll talk about what that means in a little bit tomorrow. My explicit formula, I'm going to take this part and just copy that whole thing also. So for any step, AN is, well, my first term is 16, plus my common difference is -3 times n minus 1, and this works for n is greater than or equal to 1. Okay, so I have created my two formulas. This is my recursive formula, and this is my explicit formula, and now I'm done for this slide. Okay, my last example for today. This is another type of question that I'm going to be asking you about arithmetic sequences, and it's to find the 43rd term of the sequence. So my first step is going to be, I'm going to use the explicit formula for the sequence. So to do that, I actually need to go back and write my explicit formula for this sequence. So I'm going to do that. In step 1, I'm going to write my explicit formula. My first term is 1. What's my common difference? It looks like I'm adding 11 each step. Okay, so my A1 is 1, and the common difference is 11. So I can write AN is equal to first term, which is 1, plus my common difference, which is 11, times n minus 1. Okay, so then I have my explicit formula. This works for n is greater than or equal to 1. If I need to find the 43rd term of the sequence, so I've finished step 1. I have my explicit formula. The 43rd term of the sequence, this is a step number. So my step number is n. So for this formula, for this step, I need to identify step number we need. So what's the step number we need? Well, the step number we need is 43. So n is 43 for this problem. So to solve for this problem, I'm going to write A43, because that's what n is equal to 1 plus 11 times, well, 43, because that's my step number. So now I need to use the order of operations to simplify this whole thing. 43 minus 1 is 42. So I have 1 plus 11 times 42. 11 times 42 is 462. And trust me, I used my calculator because I Okay, so A43 is 1 plus 462. So A43 is 463. There's my answer. So the 43rd term of this sequence is 463. This is the 43rd term of the sequence. And I'm done now. There's one more problem for you to finish up on Nearpod, and then you are done for the day.